friends, I welcome you all once again to the episode of Decoding the Quantum Mechanics. Today we will discuss whether there is a classical explanation of photoelectric effect. There absolutely must be. If light is an electromagnetic wave, it must explain what is actually happening in the photoelectric effect at the position of the electron. When the photoelectric effect was discovered, everyone was surprised to see why the kinetic energy of the ejected electrons depended on frequency. Everyone thought that if light is an electromagnetic wave, energy of the ejected electrons should depend on the strength of its magnetic field, means intensity of the light. This expectation was completely wrong. It is hard to understand why everyone was insisted on energy, since photoelectric effect was instantaneous. Therefore, a force must play an important role in this effect. At that time, everyone agreed that electron was a particle with electric charge. And it was also well known that displacing any particle requires either a force or collision of another particle. So light is an electromagnetic wave and the electron is a charged particle. So the electromagnetic field of that light can apply force on the electron in this process. Perhaps we had pursued this direction, we could have found a right solution to the photoelectric effect. It's surprising why everyone stuck to energy without considering this. And for over 100 years, we have been blabbering that classical mechanics cannot solve this effect. In all this time, no one thought to consider the force. How amazing! Consider a light wave with wavelength lambda falling on a metal surface and explore how it might interact with the electrons present there. So this is a light wave. Its length is lambda now here, one wavelength, and its electric field we have taken here only because initially electron is at rest, and this electric field gradually interact with the electrons. And consider a particular situation where electron at the metal surface is at the position of the electric field. Clearly, now we expand this region. Clearly, the electric field around the electron is not symmetric. Here is high and here is weak. Therefore, the electron will not go straight along the force, but it must follow a curved path. To understand the impact of asymmetry here, we need to recall Newton's third law, which states that for every action there is equal and opposite reaction. This means that forces always exist in mutual interaction. First tell me, do you agree with this? You might be little confused. It is simple statement, but I don't know why we have lost our confidence. We teach this to the students, so why we should get confused? We should realize that a force can be generated between two bodies only when they interact with each other. Okay? Now consider the electric force applied by an electromagnetic wave on an electron. If E is an electric field of the wave at position of the electron, then the force can be given by F is equal to minus A into capital E, where minus E is the charge on the electron. Actually, this is the action, but in a reaction, the electron also applies force on the electric field of the wave in such a way that the electron has its own electric field and it can apply force on the charge associated with the electric field of the wave. But the electric field of the wave has no electric charge, but force must be existed in mutual. So the option remains that the electric field of the electron must apply force on the electric field of the wave. It is the fact done. That is, if it is the fact, then the electric field of the wave must be applying force on the electric field of the electron, not on the charge. Thus, two independent electric fields interact with each other to produce the electric force between them, which may be called as the force through field interaction. Thus, the electric charge has no role in the existence of electric force.
Further, the electric force equation F is equal to QE is not sufficient to explain this situation. It is to be generalized in the form of interaction between the two fields, which is not done yet.
Look, we simply implemented the idea that force is mutual and found that two independent electric fields interact with each other, generating a force between them. Until now, we believed that electric fields only apply force to electric charge, which is completely wrong. In fact, electric force is generated by the interaction between the two electric fields in which electric charge plays no role. So we can't confidently say that an electron has an electric charge. But we can say that an electron has an electric field associated with it. We can't even say that its charge is responsible to produce the electric field.
This means that the repulsion between two electrons is not due to their charges but due to their fields in terms of field-field interactions. If we haven't even figured out this out of all these years, what are we doing? We still saying this mechanism can't explain this, but that mechanism can. What kind of foolishness is this? So now the question arises, what did Robert Millikan measure using the Eldorf method in 1909? In fact, he measured electric force and found the value of an imaginary electric charge on the electron. That's all. Let us assuming the existence of electric force in terms of field-field interaction, we try to solve the matter means the photoelectric effect. Let us analyze the electric field of light wave over a half wavelength by dividing it into three distinct regions. When an electron resides in the lower region, it will follow this curved path, means it get pushed further into the metal, preventing any photoelectric effect from occurring. In the middle region, the electric field is symmetric, which means that the electron is pushed parallel to the surface, again leading no photoelectric emission. However, in the upper region, the electron travels along a curved path, but in upward direction, which can result in its ejection from the metal surface, thus producing the photoelectric effect. Therefore, it is crucial to explore the dynamics within the upper region of the electric field. Now we consider the electron residing in upper region of the electric field. In this case, as the electron follows a curved path, which shows that two forces must be present. One of these is the effective electric force, which must act in opposite direction of the electric field of the light wave and be proportional to the amplitude E0 of the electric field. The second force that changes the direction of the electron must be perpendicular to the velocity of the electron and inversely proportional to wavelength, which is called an apparent force Fa. The combined work done by these two forces, that is effective electric force and the apparent force to remove the electron from the metal surface, will be proportional to E0 by lambda or nu into E0, as nu is the frequency and is inversely proportional to the wavelength lambda. Some of the work done by this must be spent freeing the electron from the metal surface, which can be called as a work function. And remaining amount of energy will be converted into kinetic energy of the electron. So the equation for the photoelectric must become this. This equation is a purely empirical equation that illustrates the trend when viewed through the lens of classical theory. While deriving this equation, it was assumed that work is the product of the force and distance. Therefore, the maximum force applied by that light wave should be proportional to E into capital E0, where E is the charge of the electron and E0 is the maximum value of the electric field. So naturally, the maximum work done on the electron should be proportional to the amplitude of the electric field. In that way, further the direction of the kinetic energy at that time gained by that electron should be parallel to that of the field. But due to the apparent force, the direction of that velocity changes. The rate at its change depends on how small the wavelength of that light wave is or how high the frequency is. Therefore, the work done to pull that electron out of the metal surface should be proportional to nu into capital E0. Certainly, it has not yet been established the distance up to which the effective electric force influences the electron. It is possible that the comprehensive understanding will only be achieved following the generalization of the electric force via field-field interaction, which could potentially be a complex issue. However, Einstein's equations do not include E0, but one thing should be noted that it is the amplitude of the electric field in the light wave generated due to the oscillations of an electron in the atom. It is our belief that light waves are generated by the transition of electrons within atoms, a notion that is incorrect. If an atom emits light waves of a specific frequency, it follows that at least one electron within that atom must oscillate at the frequency of that light wave. Further, the electric field of any electron is always constant, we know, and the same consequently the amplitude of the electric field in the light wave created by it may be constant and the same for every light wave, whatever may be its frequency. This means that the k is 0 can be equal to a product h as Einstein's equation, and it is now very satisfying that Planck's constant h is being linked to some physical things, means E0, and means the field of the electron. Otherwise, H would have no basis until now. Further, when Einstein says that in the photoelectric field, an electron absorbs one light quantum at one time, then of course one light wave can interact with an electron at one time, which is probably giving very important signal. Otherwise, Einstein's mere statement would have no meaning.
because the apparent force only changes the direction of the electron. It may be actually the magnetic force generated by the asymmetry nature of the electric field. This means that the magnetic field does not have independent existence, which is an important point to be noted here. Furthermore, the apparent force increases with frequency as we have found. This means that if frequency of any electromagnetic wave increases, the magnetic force exerted by it should also increase, which could be the main reason for the photoelectric effect. Furthermore, where the electric field is a maximum or highest, the apparent force is a zero, which means that the magnetic force there must also be zero. Further, when the electric field is a zero, at that time the magnetic force must be non-zero. This means that there must be a phase difference of 90 degrees in the electric field and imaginary magnetic field of any electromagnetic wave. This goes against current electrodynamics, which states that in any electromagnetic wave propagating in space has a zero phase difference between electric field and magnetic field. If this happens, it will cause a lot of confusion. It will be hard to believe. First, electrodynamics will be in danger because the magnetic field actually has no physical existence. So half of it means the entire theory of magnetism will be put on trial. Question will also arise why we have been carrying it around all this time. Why haven't we suspected its existence until now? Even when magnetic monopoles don't exist in the universe, the magnetic field still exists. Does this mean we are making a mistake in understanding it? This question should have arisen in our minds long ago, but we have been searching for magnetic monopoles for years. The reason is that instead of truly understanding the laws or nature of the universe, we have become more interested in binding them into mathematical equations, and we have been proud of it also. There is a saying in quantum mechanics, shut up and calculate. Very good. What a great idea. This is a great way to shut up. Now we don't even know what are we saying. Let us first see if we can design an experiment that will verify that increase the frequency of electromagnetic wave, increase the magnetic force, and that there is a phase difference of 90 degrees between the electric field and the magnetic field.
Understand this, we need to understand how a cathode ray tube or CRT might behave in the presence of electromagnetic wave generated by an electrical antenna. To analyze the response of the electrons of the beam of CRT, we first divide the electric field of the wave into several sections. In section AC, the electrons in electron beam get decelerated, so they will get pushed into the strong region of the electric field. At point B, D, and F, the electric field is a symmetric, so electrons will not get deflected. In section CE, electrons are being accelerated. They will get pushed into weak region of the electric field. Further, the deflection of the electrons must be inversely proportional to the wavelength, means must be proportional to the maximum asymmetry, and hence directly proportional to the frequency for a given amplitude. This can be experimentally verified. Now, if we apply magnetic force equation to the deflections of the electrons in the CRT beam, it will give expected waveform of the magnetic field as shown here. Clearly, it shows that the phase difference of 90 degree in between the electric field and a magnetic field, which is not expected by the formal classical electrodynamics.
This shows that one can design an experiment to get the evidences. For that, we can use an electric antenna to generate electromagnetic waves of the required frequency and required strength. We should be able to verify its frequency while keeping the electric field strength constant. Two CRTs can be used to test the electric field strength and the magnetic field strength. The required frequency range of electromagnetic waves can be set using the CRT dimensions to get the appropriate or correct results.
This is the experimental setup to check increase in magnetic force with increase in frequency. The deflection given by CRTX will be proportional to the electric field strength of the wave. One can set the field strength constant and increase the frequency keeping the constant deflection of CRTX. CRTY will give a response to the magnetic field strength according to formal electrodynamics. One can check if this increases as the expected with increasing wave frequency, because we know that by using our analysis, this deflection is produced due to the asymmetry of the electric field. And formal electrodynamics says that this deflection is due to the magnetic field. If we found that increase in frequency means increases asymmetry, if it increases the deflection of the CRTY while keeping the field strength constant, then we can directly say that the magnetic force which must be responsible to produce the photoelectric effect. Now, another task is to check experimentally phase difference between electric field and magnetic field, and this is the experimental setup. Now, to check the phase difference between the electric field wave and magnetic field wave, a common appropriate ramp signal can be given to both the CRTs to produce the waveform, and through the waveform we can check is there any phase difference or not. Other method can also be used. The signal given to the antenna can be fed to both the CRTs simultaneously, which will produce Lissajous pattern. If one CRT produces a straight line and another CRT produces ellipse, at that time we can say that there is a phase difference of 90 degree between these two waves. Friends, current electrodynamics tells us that there is a zero phase difference between the electric field and the magnetic field in any electromagnetic wave propagating in free space. When we conduct the experiment described above, it will definitely show that there is a phase difference of 90 degrees between the two. There is no doubt about this. In fact, the magnetic force is generated due to the asymmetry of the electric field in that wave. So the electromagnetic wave contains only the electric field. Now by measuring the polarization of photon, we are only measuring the polarization of electric field. You can imagine what this will achieve.
This will prove that the magnetic field does not exist independently. It will be proven that the electric field is responsible for creating the magnetic force. Therefore, it will also be proven that the magnetic monopoles will not be found in the universe, for which many people have wasted their lives in searching. How will their lives be compensated now? How terrible this will be. The next question will be whether the asymmetric component of the electric field is responsible to produce the magnetic effect, or whether the force generated between the parallel components of the two independent electric field is producing the magnetic effect. It is interesting. This topic will be very important for a research point of view. I think the latter should be true. Means the force generated between the parallel components of two independent electric fields might be producing the magnetic effect. Because when two electrons are at rest, only electric force is generated between them. At that time, they have only radial component of electric field. When these two electrons come into spin motion, their electric fields also acquire tangential components. Now the magnetic force arises, and it may be only due to the tangential component of the electric fields. Further, the asymmetry also arises only in the tangential or parallel components of the electric field. This means that the electric field itself is generating two types of forces. It's a radial component producing existing electric force, and it's a tangential or parallel component producing the magnetic force. In the photoelectric effect, when an electron accelerates, its electric field also acquires a tangential or parallel component, and the electric field of a light wave already has a tangential component, meaning the magnetic force generated there may be due to the interaction between both the parallel components of the electric fields. This means that the magnetic field does not exist in isolation. We should have known this beforehand when we were developing the mathematical formulation of the magnetic field in the absence of magnetic monopoles. We should have considered how many types of fields could exist in the universe. In fact, there can be only one field in the universe, and if it is electric field, then there can be no other field, not even the gravitational field, to exist. Simple observations reveal how strangely we have thought about magnetic fields, yet no one has noticed it. For example, the case of magnetic field produced by a direct current or a straight current.
Let us investigate the field produced by a straight current. We know that a magnetic field has an effect of an electric current. If an electric current flows in a straight line, how can its effect be circular? That is a big question. The, this effect must be straight, means parallel to the current. This suggests that the current may be producing a parallel electric field as shown by the blue arrows. This also means that the force between two parallel currents is not due to their magnetic fields, but rather due to the electric force between the parallel electric fields produced by these two currents. Question arises that what kind of field around the earth is. If a straight current creates a parallel electric field, a coil should produce a circular electric field having two field cones at its end. Therefore, it can be realized that the Earth should also have a circular electric field having two field cones at its poles on which the strength of electric field should be high, that is on the surface of the field cones. That is why the aurora formed on Earth or on the planet means on the Saturn too appears in the form of a circular ring. Otherwise, if the magnetic field was a reality, then the aurora activity would have been in the form of patch where the intensity of the magnetic field is strong, but the aurora appears in the form of a ring, which means that the activity of formation of aurora on the surface of the cones is strong.
Friends, we have seen that light is simply a wave nature. This means it contains no photons. Increase in the frequency of any electromagnetic wave increases the magnetic force acting on it, and this is what causes the photoelectric effect. Again, any electromagnetic wave has a 90-degree phase difference between the electric field and the imaginary magnetic field. Actually, light wave or any electromagnetic wave contains only electric field. Both of the above can be tested experimentally. This proves that the magnetic field has no independent exist. This also answers why magnetic monopoles are not found in the universe. Moreover, the polarization of the photon being measured now is the measurement of polarization of the electric field of the light wave only. Therefore, if there are no photons, there is no reason for their entanglement. Therefore, no communication system based on photon entanglement can be developed. All this is clear. Again, light has no particle nature. So half of the wave particle duality on which quantum mechanics is based is lost. Therefore, it is not surprising that no one understands quantum mechanics because it is based on the false foundation. In the next episode, we will look in detail at what actually happened during the development of atomic structure, which will be very interesting. Till then, thank you for being with me.
For further information, you may read the papers. One is Classical Explanation of Photoelectric Effect published by IEEE in April 2025 with DY number this. And another is On the True Origin of Quantum Nature in Atoms, a Missing Story, a preprint published by Sci ELO in 2025 November with DY this. Thanks once again.